Modern machine learning models are extremely powerful, but there is a major problem. Most of the time we treat these models as black boxes. But when it comes to safety critical systems like medical image processing or autonomous systems, we need to make sure that we understand what is going on inside the machine learning model, and it is not just trying to find shortcuts. Rather, the model must know what to do. And so that is why we are using explainable AI or XAI. And previously, the most of the models were convolutional neural networks, and methods like Grad-CAM were very useful. But now we are using much advanced vision transformer models where it is much harder to visualize what is going on behind the scenes, because multi-headed self-attention uses these attention heads to process different aspects of the input, and some aspects might be really important for our final task while some other may not be that much useful. They might be just redundant. And previously, most of the methods that were trying to understand these vision transformers were using attention rollout. And what is happening inside the attention rollout was that at each step, at each of these attention heads, they are extracting the attention matrix and they are multiplying it. They are also adding the identity matrix to account for the residual connections. But this weights all the attention heads in a similar way. But that is not good because that dilutes our information. As a result, we need to measure the relative importance of these attention matrices. That is why we create a set of weights. How are we going to create these weights? So we assume that an attention matrix is going to be sensitive to the output if it is more influential, and that is why. So we take an input image, we pass it to the model, we calculate the output logics, and then we backpropagate the gradients. If the gradient is high in a certain attention head, that means that attention head is more sensitive to the output. In other words, that attention is carrying a lot of hard work, and that is, as a result, that attention head must be given a higher weight. So that is the idea behind weighted attention matrices, and we call this approach gradient driven multi-head attention rollout. So it is exactly the same idea just like the attention rollout, but now we are giving them relative weights, and these weights are being normalized, and the n units of attention maps are being multiplied element wise with these head weights, and the output rollout image is being generated. So this approach has become extremely important for modern day applications like medical image processing.